Hello everyone. I'm sorry for late. Wel welcome to Facebook Live. My name is Judy. Today's topic is going to introduce about BGP. Have you ever heard about BGP or you are familiar with BGP? Comment it, let me know. Ray is one of SPOTO instructor. His main courses are routing and switch and security. If you have any question about routing and switch and security, please feel free to ask him. You can find him in SPOTO Cisco study group. Our study group link is in the comment. Join our study group and email to me and leave email to get study material now. I will send the study material to you through the email in 3 days. And we're going to talk about how does the internet work, what's the routing protocol, usage scenarios of BGP protocol, how to use the BGP protocol to control the network, BGP insertion knowledge by a qualified network engineer, review the network structure of an international company. This leaf will help CCNA to understand what is the internet, what is the routing protocol. For CCNP, you will understand why to use BGP, where to use BGP in the network. How does the BGP protocol work? For CCIE, how to use BGP protocol, understand large network infrastructure. Before re-speaking, please allow me to introduce SPOTO to you. SPOTO in IT certification, training, and winning grade firm in Cisco, CISSP, AWS, Huawei certification, online training, and providing superior study material in the work over 16 years. SPOTO shares its reputation with practice test over 98% passing rate, faster pass, 1-to-1 service, and 7 days 24-hour customer support. Today, SPOTO is certification preparation product continue to be an integrated part of world certification market. Over the last 16 years, SPOTO has achieved many accomplishments. On 18 February 2000, found head office in Fuzhou, China. In January 2007, branch company was founded in Shanghai. In 2008, it was authorized to become strategic partner of Rtds, the technical service center of Star Network company like Huawei. In August 2012, SPOTO helped over 100 members got CCIE certification. On 14 May 2013, the form with President of Cisco China region guide the development director of SPOTO. On 24 May 2014, SPOTO launched the first CCIE conference in Fujian province. In September 2014, SPOTO successfully met the transformation of online institution. In 2015, SPOTO became a training base for IT talents in universities such as Fujian Engineer College, Sanya College, and Fujian Normal University. In February 2016, SPOTO became the top of Cisco certification training company in China. The November 2016 Huawei certification and new network security product were launched. Is that I heard some people, maybe my voice is a little bit too low, but I try to be loud. In January 2017, SPOTO entered the IT International Certification Training. In July 2017, SPOTO was awarded the annual official certification of Tencent Classroom. In September 2017, SPOTO launched CISSP training product. In January 2018, SPOTO and Anhem reached a cooperation in the security field. In January, SPOTO was awarded by Fujian Top 10 Influence branch. In July 2018, SPOTO was awarded the annual official certification of Tencent Classroom. In July 2018, SPOTO helped one member, the first one in the world, pass CCIE wireless version 3.1 lab exam. In September 2018, SPOTO won the Rocket Agency Award in Tencent Classroom. In October 2018, SPOTO helped 1,000 members get CCIE certification. In November 2018, Linux Red Hat certificate product was launched. You can, in February 2019, SPOTO helped 1,200 members get CCIE certification. You can research SPOTO to know more content of SPOTO YouTube channel. In past 16 years, we have seen it all successful and failure, highs and lows, celebrate and cries. We have gone through so much up and down, but one thing we never did was to give up, said Alex Hu, President and CEO. Let's never give up spread, following SPOTO method, choose, move, persevere, go beyond, which have brought us to where we are. Top IT certification training company in China and sharing good fame in Cisco certification training overseas. Continue Alex Hu. It's a matter of great pride to see our company growing, imbalance good value system, and achieving more than what we have ever thought of. I would never have been able to picture this successful journey without you people. Your support and trust for SPOTO contributed a lot to our growth, and I want to thanks for that. Thanks for all of your support and trust. SPOTO will be your best choice in IT certification. Trust SPOTO. Trust your choice. At Alex Hu. About SPOTO, SPOTO is a abbreviation of 5 words: service, professional, outstanding, teamwork, obtain, which means our company will provide professional and outstanding service to all of our clients. The client can get their certification with the assistance of our patient or professional lecturer. Our company was founded in February 2003. Till now, we have more than 16-year IT certification training experience. For 16 years, we launched Cisco, Huawei, CISSP, Red Hat Linux, AWS, and other IT certification training courses. And practice test. SPOTO has its unicorn company culture. Follow metal reflection SPOTO cultures. When you choose to be CCIE, you are already CCIE. Choose move, persevere, go beyond. It's easy to persevere with a group than to persevere by yourself. Every CCIE member has its own story, and being a CCIE is a beginning of your career. Google it. Google CCIE-dumps.spoto.net. Find more information about SPOTO. And don't forget to join SPOTO CCIE study group to get study materials. Also, you can discuss more questions with instructor in the study group. Now it's time to speak about BGP. Welcome back to SPOTO Facebook Live.
Yeah, hello everyone. So first, can you hear me clearly? Just like this? Is the voice okay? Okay, so thanks for Judy's introduction, and then we'll start our today's live class, okay? Okay, so is the voice too low or is okay? Yeah, okay, so good. And then we will start our today's live class. This class we mainly talk about the internet, we talk about routing protocols, and then we talk about the BGP routing protocols, okay? So this class we mainly divided it into 4 parts. We can see it here. We have first we need to know what's the network, and the next what's the route, what's the routing protocol, next what's the BGP routing protocol, and we need to know how to use the BGP protocol to help us control the network. And the last part is we need to know about the network structure. Okay, so this part are from easy to difficult. So first, I want to ask you a question. So in your real life, how can you contact with your maybe your colleagues, your friends, and your families? So it's a very simple question. Yeah. So I think maybe we have too many ways to contact with our friends. Yes. So maybe Facebook, maybe the Twitter, maybe WhatsApp. we have a lot of apps. And for this topology, we can see it here. It's a very simple situation. Maybe the re is me. Yes, just like this here. Yeah, just here, re is me, and Chen is my friend. And maybe one day I want to say hello to him, so I send an email to him. Yes. And I think the email is widely used in our real life. So in this situation, I just write an email, and the content is hello. I just said hello to him. And for this process is the communication between me and my friend Chen. And in this process, we have 5 different key points here. So to help us complete this communication process. Okay. So we have 5 different key points. So first, I'm the sender, yes. So Chen, my friend, is the receiver. And we need to have the sender and the receiver. And then next, we need to write a message here. So in this here, I just write hello here. So this is the message I want to send it to my friend. And then next, we can see here the language is English. I need to ensure my friends can understand this language. Yes, so that he can understand what I try to talk to him. If I maybe I write Japanese here, so I know my friends can't understand Japanese, so he can't understand what I try to talk to him. So maybe it's difficult. Just like in this time, for this live, I talk Chinese. Maybe you all can understand this. Yes. So language is also very important in this process. And then next, the last one is this message will be transmitted through the internet. Yes. So the first question is I want to ask us, what's the internet? Yes. Okay. So in our real life, we usually use different ways to communicate with each other, and for these messages will be transmitted through the network. And our question is, what's the network? So next, we can find the results here, just like this. So I can say for this topology, we have 2 different PCs. Yes, we have 2 different PCs, and they just connect directly. So this is the simplest network. So this is the simplest network, and this network can achieve the aim to make us exchange some information, to make us communicate with each other. So this is the network. And for this, the simplest network, if these 2 different devices need to communicate with each other, we also have 5 different key points, just like the process in this page. We also have the 5 key points in this topology in the network. The 5 key points is also the first one. We need to have the sender. So the sender is just like here, the PC1. And in real life, I have a name. My name is Ray, so I'm the sender. But in the network, the sender have an IP address. So it's just like the name of me, and in the network is the name of the device. So this is the IP address. And then we need to have a receiver, yes. So in this time, PC2 is the receiver. And the IP address of PC2 is 10.1.1.2. So this is the name of the PC2, this device. So the first 2 key points is the same with the real life. We need to have the sender and the receiver. And then next, we need to have the date. We need to have the date. We need to have the message. So the message is like this, just like this one. It's in the real life, the message is just the email. And in the network, the message is just like this. We call it packet. It's the IP packet will be transmitted through the network. So this is what's the packet looks like. So it's just look like this. We can find the IP address of the sender and the receiver is used to tell us what's the source address and what's the destination address. So this is the that, and then next we need to have the same language. Yes, but in the network it's called protocol. And if these two pieces wants to communicate with each other, they need to use the same protocol. Just like I need to speak the same language with my friends. If these two pieces need to communicate, they need to use the same protocol. And for the last one is we need to have a medium to transmit the message. So the medium in this topology is the physical lines connected these two different pieces. Okay, so also we can conclude here in the network, this is simplest network here. If we want two devices can communicate with each other, we also need to ensure the 5 key points. The first is the sender, the second is the receiver, and next is the protocol, and the next is the medium. Next is medium, and the last is the message. We need to have the message, the data here. So for this topology, we know the simplest network. It just looks like this, and then I want to ask if the network structure is a bit more complicated. So what will it look like, and what will happen? Okay, so next we can see another topology here. Folks, this topology is just a little bit more complicated here, and we have 3 different pieces here, not like this. For this topology, we just have 2 pieces directly connected, but for this one, we have 3 pieces, and also we have 4 different routers here. And the routers is most widely used device in our real network. It's used to guide the packet to forward, so it's very useful. And we can see here from this topology we have 3 pieces and 4 different routers. And for this one, if I want PC1 to visit PC3, so if I want PC1 to visit PC3, so here we will find a question here. So the question is, the PC1 need to send the package to PC3, yes. So first PC1 will send the packet, and then when the router receives the message, we will find we have 2 paths can transmit this packet, right? So the first one is the blue color, yes, just like this, and the second one is this. So how can the router know which path is the correct? Yes, so this is the route. This is the route. We need to let the router know which way is correct. So this is called the routing information. And how can the routers know which way is the right? It needs us to configure the route information to let the routers learn the route information. Okay, so this is called the routing protocols here. So it used to let the different routers learn the different routing information here. So from this topology, we have 4 different routers. In this situation, we need to configure the routing protocols. So maybe in this situation, we configure just like OSPF or static route information, so that the RTA, this router will find if PC1 wants to visit PC3, the router will know this packet need to be forwarded to RTC, not RTB. Yes, so that the RTA can know this, and then the RTC know if PC1 wants to visit PC3, the packet need to transmit to RTD, and finally RTD finds the PC3 is directly connected to it, so the RTD forward the packet to PC3, and so this is the process that PC1 communicate with PC3 in a little bit complicated network here. And because we have different routers and we have different network segments, and it means we have different paths to forward the traffic, so that we need to run the routing protocol to let the routers learn the routing information to know which way is correct. Yes, so we configure the routing information here to let the RTA, the correct path is the yellow one, just like this. Okay, so this is the route, and this is why we need to use the routing protocol here. So, and we just said this topology is a little complicated. Yes, it's just compared to this topology. We just have two devices here. It's very simple. And for this one, we have seven. Devices. It's actually it's not difficult yet. It's just a small topology. And for this one, we can see here. For this topology, it's more like a real network structure in our real network. Yes, it's maybe your company's structure is just like this. It's a medium-sized network structure. It's just like this. And we can see here, first we'll find the number of the device is much larger than this one. Yes, it's just 7, it's just 2. It's much larger than this one. And next we will find in this topology, we have different layers here. And in this topology, we have different layers here. So we can see here, when we deploy the network structure, we usually divide it into 3 layers. The first one is the access layer. This is the access layer. And the second one is aggregation layer. And the third one, for this one, is the core layer. It's the most important layer in our real network. And we need to know why we need to divide the network into different layers, and we need to know the different layers has the different functions here. So first, why we need to divide the network into different layers? Because we need to build our network. We need to make sure in which position we use which devices, and for the devices, what's the function of these devices. So that we usually divide the layers when we try to build the network. And in this situation, we divide the network into 3 different layers: the access, aggregation, and the core layer. So next, let us talk about the why let's talk about the which device we used in which layers. Okay, so from the access layer, we can find it here. We usually use the switches in the access layer. Okay, pay attention. We usually use the switches here in the access layer, because for the function of the access layer is used to provide a large number of the interface to let our devices can access to our internet. So this is the function of the access layer. So we all know that compared to routers, the switches has a large number of the interface. So we use some switches in our access layer to provide a large number of the interface. So this is the function of the access layer, and we usually deploy the switches here. And for the next layer is the aggregation layer. And we have a large number of the devices here, maybe depart A, depart B, and depart C. We have a lot of stuffs here, so they all have their device. So this device will generate a large number of the traffic. Yes, they need to visit the internet. So we have a large number of the traffic to visit the internet, just like this, just like this. So this red lines means the traffic from our company to visit the internet. Okay. So from the access layer, we will have a large number of the traffic, and for the aggregation layer, we also usually deploy the switches here, but the function is not the same in the aggregation layer. We usually use the switches to control the network. So for example, maybe we can change the priority of the traffic. So for this one, maybe we have 3 different traffics, number 1, number 2, and number 3. So I can set the priority of the different traffickers here. So maybe I think this one is the highest priority. So it means when our maybe our network quality is bad, so this number one traffic with the highest priority will be forwarded at first. You know this? So I just change the priority of the traffic. So this one will be forwarded at first. So this is the function of the aggregation layer. It can help us control the traffic. And for the last one is the core layer. And for this layer, I can say that this layer is the most important layer in our network. So it means in these layers we need to deploy the devices with the highest performance here, because we need to ensure that these devices they need to have the strong ability to forward the packet through the our network. Yes. So in our network, we have a lot of departments, and each department will generate a large number of the traffic. So we'll find if our staff wants to visit the internet, we'll find all the traffic will be transmitted through our core layer. Yes, and in this layer we usually deploy the routers here. Okay. So in this layer we usually deploy the routers here. So this is the out interface of our network. We will find all the traffic will be transmitted through the device. So we need to ensure the device has the enough ability to forward all the traffic here. So we can say this layer is most important in our network. Yes, so this is the core layer. We usually use the routers here, and also we can find here for this symbol it means the firewall here. It means firewall. And for this device is used to ensure the security of our network. Okay, it can discuss some packet from the internet. Maybe someone want to attack our network, so the firewall can discuss the packet from the internet. Maybe someone want to attack us, the firewall can refuse it. Okay, so this is the network structure of maybe a real internet company. And in this topology here, and we have different departments. It means we have different network segments here. And if we want them can visit each other, yes, we need the different departments can visit each other. Yes, and also we need to ensure the departments can visit the internet, so that we just talk about what's the route and what's the route information. So in this situation, we need to configure the routing protocols here. And for the OSPF routing protocol is widely used in the company here. So in this situation, we need to configure the OSPF protocol in our company. And this protocol is the link state protocol, and it has a lot of advantages here to help us to calculate our rules here to make our company can visit the internet. So this is the OSPF protocol here, and we usually use this protocol inside our company, and we need to pay attention to this point. We use this protocol inside our company here, just like this. Okay, so this is one company here. From this topology, it's just one company. And if we have another situation, maybe we have two different companies, or maybe we have a very large scaled companies here. So we see the next page is just like this one. So maybe we have two different companies. Maybe we have a large scale company here. Maybe the large company has the headquarters and has the branches here. So maybe the headquarters is in USA and the branches in China. So that we need to ensure the headquarters can communicate with the different branches. Yes, and we will find maybe the there's a long distance from the headquarters and our branches. It means they are far away from each other, and also the headquarters and the branches are also very big. It means we have a large number of the route information inside the headquarters. So maybe this is inside, and we will configure the OSPF inside the headquarters. And it also has a large number of the route information, and also for the branches we need to configure the OSPF here, and also our branches also have a large number of the route information. And the question is, we need to let the headquarters and the branches, so I mean this is the headquarters and this one is the branches, we need to let these two part can communicate with each other. It means in the network they can communicate, yes. So in this situation, and we just know that we have the OSPF protocol. For the OSPF protocol, we can use it to calculate the route and generate the routing table to guide the router to forward the packet, yes. And the question is, if these two companies has a long distance from each other, and also the numbers of the routing entries are very large, so can we still use OSPF here? So this is the question. Okay. And for this situation, and I just said in this topology, we use the OSPF protocol inside the company. Yes. So it means we can't use OSPF protocol here. And I just said we have two questions: is the distance is too long, and then the routing entries are too large. So in this position, so in this one, so we can't use OSPF here. Okay. And then next we need to know so in this part we need to know about the routing protocols. For the routing protocol, we can divide it into two parts. The first one is the IGP protocol, and the second one is the EGP protocol. So next we see what's the IGP protocol. It means it's used to run inside an autonomous system. I just call it AS. It's used to run inside an AS, and it includes RIP, OSPF, and we just know OSPF. We will use it in our company, and it's most widely used in the company. Yes. And the next one is the exterior gateway protocols. It's called EGP protocol, and it's used to run between AS. And for the EGP protocol, we mainly have one protocol called BGP. Here. And for this one, we have another definition here. It's called AS. Yes, maybe we don't know what's the AS. And then AS is the definition of the AS is a set of the IP networks and routers under one administration entity and with common route policies. So this is the definition of the AS. So maybe it's difficult to understand. So to put it simply, we can just set one for this part. One company is one AS. Okay, it's a set of the routers with the same route policies with the same administration. So we can just set one company is one AS. Okay, one company is one AS. And for this part, I clear it first. Okay, for this part is one AS, and for this company is also one AS. Okay, and we need to use the AS number to indicate the AS. So for the different AS, we have the different AS number. Its AS number is used to indicate the AS. So maybe for this one, for this part, the AS number is AS100, and for this part is AS200. And for the AS number range from 1 to 65535. So this is the range of the AS number, and we just use it to indicate the AS. And for this situation, we just set this AS is 100 and this AS is 200. And then next we just learned about the IGP and the EGP. Yes, for the IGP is used inside an AS, and for the EGP is used between different AS, so that we can find here for this company is one AS, is one AS 100, and OSPF is used inside the AS. Okay, it's used inside the AS, just use here for in this red cycle. And for this one, AS 200, and inside the AS we'll use the OSPF here. Okay, we use OSPF, and then we know the EGP protocol. The EGP protocol is used between different AS. Yes, so just in this here, in this position, and in this between different AS, we need to use the EGP protocol. And in the EGP protocol, we mainly have BGP protocol. So in this situation, we will find for this topology, we have two different companies. They need to connect each other, and in our company, we need to run the OSPF protocol to let the devices in our company to calculate and generate the rules. And if we want our company can communicate with other company in this situation, we are in the different AS, so we will use the EGP protocol here. So this is the EGP protocol, and for the EGP protocol, we just use BGP here. Okay, we just use BGP here. Okay, so maybe some of you may ask a question. So what's the difference? Yes. So why we can't use OSPF here? And to put it simply, the IGP protocol can't have the ability to carry such large number of the routing entries. Okay, but the EGP protocol have the ability to carry the routing entries. So this is the difference between the IGP and the EGP. And so I repeat it again: the IGP protocol can't have the ability to carry such a large number of the routing entries here, but the EGP protocol can. Okay, so maybe for the EGP protocol, it just can carry maybe 40,000 entries in the OSPF protocol, but for the EGP, he can carry 400,000 entries. It's okay for him. So this is the simple difference between the EGP and IGP. Is the routing entries. The OSPF can't carry such a large number of the routing entries, just like this. Okay, but for the difference between the IGP and the EGP, it's not so easy. Okay, it's not so easy. So we need to learn more about this one. Okay, so we just say next. We just learned about what's the IGP protocol and what's the EGP protocol. Yes, we learned about what's the AS. So next, for this topology, we have 8 different routers, and they are in 3 different AS here. So this one, for this one is AS65000, and for this one is 65001, and this one is 002 here. So I just said number 1 and number 2 here. So after we learned about the EGP and IGP and AS, so I want to ask us, where is the BGP protocol used in the finger? Number 1 or number 2? Yes, I think maybe this is the either question. Yeah, we can see here. This question is easy. So number 1 and number 2. So in which location we need to use the BGP protocol? So I think it's easy. We just remember the definition of the EGP, and it's used to between the different AS here. Yes. So between the S6500 and the 65001, and for this location we need to use the BGP protocol. Yes, because they are between the different AS. Okay, so the same for this we need to use the BGP here. Yes, for the BGP here. And for the BGP protocol, and we have the different relationships here. And when we try to learn the data communication, no matter CC, IA, NP, or IE, and for the different routing protocols, they have the same feature. If we want to configure one protocol and we want to let them to exchange some packet to learn some information, they need to establish the relationship at first. Yes, and in this situation we called it the neighbor. So in BGP is the same. If we want the different routers to run the BGP protocol, we need to ensure first they have established the relationship with each other. Okay, so in this topology, if the these routers, maybe this A router and B router, in this situation, they need to establish the relationship, and we called it eBGP, exterior BGP protocol neighbor. This is the eBGP protocol because they have the relationship, but they are in the different areas. So the relationship between A and B is the eBGP protocol. It's the eBGP relationship. And if we run the BGP inside the areas, maybe this C and A, and for this relationship between A and C is the iBGP relationship, because this is the interior BGP relationship, BGP neighbor relationship. So we can conclude in the BGP protocol we have two different neighbor relationships here. The first one is iBGP and the second one is the eBGP here. Okay. Also, it's easy to understand if the iBGP protocol is used in the same as they have the relationship, so they are the iBGP. It means they are in the same relationship. If they are in the different relationship, just like A and B, it means they are eBGP protocol. Okay. So this is about the relationship of the BGP neighbor, and also we just talk about the difference between the IGP and the EGP here. So I just said the simple difference between IGP and EGP is EGP can carry large number of the routing entries, but the difference is not so simple. We can see here, for this position, in one AS, we usually run the IGP protocol, maybe OSPF here, OSPF, and OSPF here. So this is inside the AS, we use OSPF, and between different AS, we use BGP here. Okay, so we can see here for this sentence, IGP is used to generate and calculate routes, but BGP is just used to pass and control the routes. Okay, maybe you can't understand this word. I just explain it to you. In this AS, I just said maybe this AS is your company. Yes. So at first, before you configure the OSPF protocol, the routers know nothing. Before you configure the OSPF, the routers know nothing. After you configure the OSPF protocol, the routers will generate the route information and exchange the route information with other routers, just like this one. So we need to know, after we configure the IGP, the router will be generated and calculated to help the router to form the routing table, and the routers will forward the packet according to the routing table here. So IGP is used to generate and calculate routes, but different from the IGP protocol, we can see here BGP is used to transmit the routes from one AS to another AS. So we can see here in this topology, in this AS we have configured the OSPF. It means in this AS we already has the route information here. We already has it, but we use BGP to transmit the route information to another AS. Yes, to another AS. So maybe the route information is about the N1, I mean this is the network segment 1. I just say it N1. Okay. So maybe this the route information about N1 is used to it will be transmitted through the A router to B router. Yes. So this routing information is in the S6500, but it will be transmitted to 65001. So we can see here BGP just transmitted the routes in the S. It's already in the S. Yes. So we need to understand this. IGP is used to generate and calculate routes, and BGP is used to pass and control the routes. Okay, and then we need to learn something about the BGP and the BGP's attributes to help us to control the network. It's also very important. And so next we see for the BGP, how can the BGP control the network? Because it has the various of the attribute to help us control the network, and it means the BGP attribute. Okay, the BGP attribute, and for the BGP attribute, we can divide it into 4 different types here. And the first one is the will-knowing mandatory, and the second one is the will-knowing discretionary, and the third one is the optional transitive, and the last one is the optional non-transitive. And so we can see here the first one and the second one is both will-knowing, and the third one and the first one is the optional. Yes. So first we need to know what's the meaning of the will-knowing. If this attribute is will-knowing, it means all the routers with the BGP protocol can recognize this attribute. Okay, it means the routers can recognize this attribute. We all know this. It means we all know this. It's the will-knowing attribute. But for the will-knowing attribute, we can also divide it into 2 types. The first one is the mandatory, and the second one is discretionary. Yes. For the mandatory, it means when we use the BGP protocol here, so maybe A and B here, these 2 routers here, and we have the N1 route information. This is the network segment. The router A need to transmit the network information to route B here. So the will-knowing mandatory attribute, it means these 3 attributes must be contained in this packet. Okay, it means these 3 different attributes must be contained in this packet. So this is the will-knowing mandatory attribute. Okay, so this is the first type, and for the second one is the will-knowing discretionary. It means all the BGP routers can recognize it, but when the routers try to send the packet, the routers need to know whether it's necessary to carry this attribute. Okay, so if this maybe this attribute, the local preference is useful here, so that the router will carry this local preference value to the packet. So if in some special situation this attribute doesn't work and is useless, so that the router will not send the packet with this attribute. Okay, so it depends on whether it's necessary. So if this is necessary, the router will send it. If it's not necessary, the router will not send it. Okay, and for the first 2 type is the will-knowing attribute. For the last 2 type is called optional transitive and the optional non-transitive. And for this one, it's optional, not will-knowing. It means maybe some routers with BGP protocol can't recognize this attribute. Okay, so this is the optional attribute. Maybe some of the routers can't recognize it. And for the optional attribute, we can find also 2 types. The first one is the transitive, and the second one is the non-transitive. It means if this attribute is transitive, it means even if this router can't recognize it, it also can transmit it. Okay, so this is the optional transitive. Just like this, maybe we have 3 different routers here. 3 different routers, and for this router A need to send a route information, maybe the network 1. For this route information need to send it to the router C here. Yes, maybe send it to router C here. And for this attribute is the optional transitive attribute. In this situation, maybe the router B can't recognize the attribute from the optional transitive attribute, and the router B can still transmit the attribute to router C here. Okay, so this is called the optional transitive attribute. For the last part is the optional non-transitive. It means if the router B can't recognize this attribute, and also this attribute can't be transmitted through the router B, so it means the router B will not recognize it, and it also will not transmit it. So this is the optional non-transitive. And we can see here the BGP has the various attribute here, and for this attribute they have the different functions to help us to control the network path here. And for the next, we need to show you a topology here, just like this one. In this topology, first we need to figure out the topology here. We have 7 different routers here, and for router ABC they are in AS100, and for the router D is in the S200, and for router EFG they are in the AS300. Yes, so we have 7 different routers in the 3 different AS, and in this situation we have configured the BGP protocol in each routers so that the network is okay here. So it means the RTA can communicate with RTG here. It can communicate with each other. But in this situation for RTA, we have the network 1 called 1.1.1.1, and for the RTG we have the network 2 called 7.7.7.7, and for network 3, the N3 is the 77.77.77.77. Okay, so for these 3 different networks, if in the normal situation, maybe the N1 network wants to visit the N2 network, the path will be transmitted through this way. Okay, so it means when N1 wants to transmit to N2, the packet will be transmitted to RTB, and RTB will send it to RTD, and then next RTD will send it to RTE, and next RTE will send it to RTG. So this is the path. This red line is the path when the N1 try to visit N2. And if we try to use the N1 to visit N3, here, and also the packet will be transmitted through RTB, RTD, RT, and RTG here. So we will find for this way, RTA, RTC, DFG is empty. We will not use this way. So it's a waste, I think. So we want to achieve the aims is when N1 try to visit the N2. When N1 try to visit N2, we want the traffic can be forwarded through the red line, through this one, through the red line. And when we use the N1 to visit N3, we want the traffic can be forwarded through the blue line. Okay, so this is the aims, but no, in the current situation, all the traffic will be forwarded through the red line. So we can use the BGP attribute to achieve our aim, because we can use the attribute to control the network. Okay, so first let's us to see it. Okay, so first is the current. First, this one is the current routing table of the RTA and RTD. Okay, so we need to figure out this is RTA and this is RTD here. This RTA, this RTD. So we can see the routing table of the RTA here. So this is the routing table of the routers, and this B here, it means this routing information is learned from the BGP protocol. The B means this routing information is learned from BGP protocol here, and we can see here for the RTS routing protocol, here we learned about the N1. This one is N1, yes, and this one is this one is N2. For this one is N2 network, and this one is N3 network, yes, because this one is this one and this one. And also we can see here, it means the RTA has the information of the N2 and N3, and then next we'll find here via 2.2.2.2. It means the RTA learns the route information from the 2.2.2. It's the name of the RTB, and we can understand it. This address 2.2.2.2 is the name of RTB. We can see here. So it means RTA will learn the route information from the RTB. It's both from RTB, so the traffic will be transmitted through the RTB here. Okay, so next is the Rtds routing table, and also we can see here we also have 3 different routing entries here. They are both learned from the BGP protocol, and for this one is the network 1, network 2, and network 3. And for network 2 and 3, we can see here it's learned from 10.1.45.5. Yeah, this is the IP address of this interface. This is the IP address of this interface. This one is the IP address of this interface. So it means if the RTD wants to visit this network 2 and network 3, it will transmit the packet to the RTE here. Okay. So we can see here, when RTA send a packet to visit N2 or N3, the packet will be transmitted through the RTB. Yes. So RTB will receive the packet and then send it to RTD, and the RTD will check its routing table. Will find it learned it from the RTE. Yes, it learned it from RTE. So RTD will send the packet to RTE, and RTE will send it to the RTG. So we'll find the situation is all the traffic will be forwarded through the red line, and we need to use the attribute to change this situation here. So in this situation, we will use the BGP attribute here, and for this attribute, we will use this one. This one is called local preference, and this one is called MED. This is the metric of the BGP protocol. We will use these 2 attributes to help us control the network. Okay. So first one, we need to use the local preference. It's the local preference, and next one is the MED. Okay. So for these 2 different attributes has the different functions. For the local preference, it's used to change the traffic which is flows out of the AS. So we can see here when RTA will try to visit the network 2 and network 3, the traffic will be transmitted out of the AS. Yes. So the local preference is used to change the path when the traffic flows out of the AS. Sorry. So for this one, when RTB and RTC send the routing information to RTA, we can change the local preference here. And for the local preference, it has a value. The default value is 100. The larger the value, the higher the priority. So we can change the value here. If we change the RTC's local preference of the network 3 here, just like we change it to 200 here. So in RTS routing table, we'll find here just like this one. When RTA learns the N3's routing information from the RTC here, and we can see here the local preference has changed. Is the local preference is 200, so it is the variable than this one, So when RTA try to visit the N3 again, so we will find the next hop is 3.3.3. Yes. So when the RTA try to visit the N3, the packet will be transmitted through the RTC here, and then next the metric, the MED, is used to change the traffic when the traffic flows into the AS. So we can see here when RTD, so here RTI visit to the N3, the traffic will be transmitted to RTC, and the RTC will transmit it to RTD here. So next we want RTD send the packet to RTF. So we need to change the attribute. The MED is used to guide the packet flows into the AS. So we can see here the MED has the default value is 0, and the less the value, the higher the priority. So it's just like the cost. When the RTE sends the routing information of the N3 to the RTD, we can change the metric here. So just like this, we can change the metric here to 100. So 100 compared to 0, 100 is larger, and for this one, RTD will select this way. So we can see it here. For RTD's routing table, we can see here. This is the routing information of the N3 here. It's this one, and for this metric is 100, and this one is learned from the RTE. This IP address is the IP address of RTE, and we just change the metric to 100, and for this one is 0. So the cost is 100, and this one is 0, and for the routing information learned from RTF will be better. So RTD will send the packet to RTF, and then RTF will send it to N3. Okay, so in this situation, we use two different values. The first one is the local preference, and the second one is the metric. It's used to guide the packet. The local preference is used to guide the traffic flows out of the AS. Yes, flows out of the AS. And for the MED, it's used to guide the traffic when flows into the AS. So this is the difference between the local preference and the MED. And so next, we can see it here. For the routing table, when the RTA, the route area trust unit N3, we can see here the next hop is the 3.3.33, and for this one it's also the RTF, it's not RTE here. And so at last we can use the traceroute to check the results here. Okay, we can use the traceroute, and the source is 1.1.1.1 to visit 7. N3. This is N3. Okay, so the first path is from the red line. Okay, so this path, we can see it here, is 10.1.24.4, and this one is RTE. So this path is the red line. Sorry, I just clear it. So this path is the red line, and then next for this path, when we use RTA to visit the 3, so this one is the blue line. This one is the blue line. Okay, so this is the original path is the red one. Okay, the original path is the red one, and the current path we can see here. This IP address, this IP address, and this IP address, this IP address, they are different. So it means we are successful to change the path to when we try to use the RTA to visit the RTG here. So we can use these attributes to achieve our aims, and we also have some different ways to achieve our aims, because the BGP has different attributes here, and we can use different ways to achieve the aim. So if you are interested in it, you can find the way. Also, you can scan the code to enter our group and it discuss with us. It's both okay. And then the last hour of our today's live class is about the large network structure. We can see here. For this network structure is much larger than this one. Yes, compared to this one, it's a medium-sized network, but the last page for this network is a very large network, and we can see here, maybe for this part is our headquarters network, just like this. And also we need to divide the network structure into different layers. So also we can see here, this is the access layer, this is the aggregation layer, this is the core layer. Yes, and for the last is the gateway device. It's used to connect it to the internet. This is the ISP, the internet server provider internet. Okay, so also we just talk about the different layers and the different devices we need to use in different layers and the different functions of the different layers. Okay, so this is the 3 layers of our network, and then we can see here in our network we have some different areas here. So for this one is the DMZ area. It's used to deploy our servers here. Okay, so we can see here, maybe this is the web server, DN server is our email server, and for this server it's used to provide to our maybe visitors or the partners. So this is this area, this is the DMZ area. And for this one is the data center of our network. And for this part is very important part of our network. It's used to provide we need to save a large number of the data in our data center. Okay, so this is maybe some important information of our network, and we need to save it here. And also the data center need to provide some servers for our different departments here. So this is the data center, and also we can see here, this is the network management system. It's used to manage our network. So maybe something wrong with some devices in this situation, and we can use the network management system to manage the network, to see what's wrong with the device and how to check it and how to recorrect it. So this is the NMS area of our network here. And also we can see here, maybe we have some partners or some visitors. They also need to connect to our network to visit our network, or also they need to access to some server here. So in this situation, maybe they need to use some different technicals here. So I think VPN is widely used in this area. The partners also some our staff on business, they need to access to our network. They usually use the VPN technical to access to our network. And next, for this area, we can see here this branches our internet, and we need to let our headquarters can communicate with our branches here. Yes, so we can see here we need to use different technicals to connect our headquarters and the branches here. So this is our branches. Maybe this branches is small here, so the network structure is not difficult, it's easy here. And for this one is the it's the wide area network is used to provide the different servers of our internet. So we can see here, so this part is our internet. Yes, so this part may be your company. Okay, this part may be your company, and this part may be your company's branches, and then also for this part it may be you. Yes, you are in one company, but you are on the trip, you are on business, so you are not in your company. So you can use different technicals to access to the internet to have some server here. Okay, so this is the network structure of some large company here, and we just talk about this one. If you are interested, if you are interested in some technicals in this topology, so you can ask me after class. It's okay. So for this one, for this number is our phone. It's my phone number. You can add it, and if you have some question about the routing and switch, and also about the firewall, you can add my phone number and ask me here. Okay. So for this part, it's all for our. Sorry. For this part, it's all for our today's the live class. And so next, I heard that Judy had prepared a special gift for us. So next time, let's welcome Judy back. Okay.
Hello, Ray. Thank you, Ray. It's awesome. I like your speech. Hello, everyone. Do you guys like it? Do you get what is BGP now and how it work? Any question want to ask Ray? Any question you want to ask Ray, please scan our QR code, join our study group, and leave email. You can hear the answer from Ray and get a free study material as well. We have good news to tell you about. SPOTO has routing and switch online training next month. If you want to know when the online training starts and how much is it, or other any question, just scan our study group to get more information or leave your email in the comment. We will email you more details. We have next online class in Wednesday. You can join our study group. We will have more information in there, and we will be there as well. Thank you for all you guys. I think time is flying when you are happy. It's time to say goodbye on the Facebook Live. However, we can meet on SPOTO Cisco study group. We are waiting for you in the study group. Okay, please scan the QR code and join our study group and leave the email. I will contact you later. Is that okay? Thank you for your thank you for your thank you, and we can meet on SPOTO Cisco study group. We are waiting for you in the study group. I hope everybody have a good night.